Probably the biggest problem that slurry-based processing companies face nowadays is to improve their production in a sustainable manner. Wouldn't it be great if you could drastically improve your production with a non-nuclear density meter? The Dutch have a long dredging history and still dominate this industry with many prestigious large projects around the world. That is why it cannot be surprising that the Alia density meter development started with the focus on the dredging industry. However, gradually it became clear that the problems related to nuclear density measurement do not only belong to this specific industry. Alia Instruments is based in Enschede, in the region Twente, a region of the Netherlands that emphasizes its entrepreneurial and tech-minded ethos. At the core of Twente's tech infrastructure lies the Twente University, one of the 4 Dutch technical universities. The offices of Alia Instruments are located at the flagship innovation campus Kennispark, right next door to the university campus. By being firmly rooted in this regional infrastructure, Alia has the support it needs to change a global industry. Alia Instruments development began with a clear goal in mind: to redefine industry standards in sustainability, compatibility, and process optimization by providing users with innovative, non-nuclear production monitoring solutions based on a straightforward gouging principle and built from industry standard components. Our engineering is the result of an innovative reconfiguration of trusted technology elements that have proven themselves in countless applications and conditions. We believe that what makes a reliable and accurate device is a comprehensive design that keeps matters simple. Okay, let me explain you the working principle of the Alia density meter. First of all, a slurry is running through the meter. And because it's an abrasive slurry, the meter is protected by a rubber sleeve. And this rubber sleeve is mounted in our measuring tube. This measuring tube is made flexible by several hinges that make it flexible so that it can move. This movement is done by an actuator that provides a known force that moves the measuring tube. And this known force results in movement that is measured by an accelerometer mounted on the measuring tube to measure the acceleration. We use the second law of Newton. Force is mass times acceleration, and we know the force, we know the acceleration, and we can calculate the mass. And because we also know the volume that is in the measuring tube, we can calculate the density. This density is calculated by our electronics box, in which a computer with an innovative algorithm calculates the density and provides it to you as a milliamp signal to your monitoring system. A simple, reliable and robust product.
Easy installation, there's no need for external commissioning engineers.
An immediate signal showing actual values. Easy integration with existing systems and software.
Unlike many of our competitors, the answer is yes. Due to the principle of the meter, our meter is not affected by the materials in the process at all. Although the initial price might seem a bit higher than the conventional density meter, the total cost of ownership is very attractive. As the only matter that we should take into account is choosing the right liner material, fitting your specific process. You do not have any RSO training costs. You do not have any disposal cost of nuclear waste at the end of lifetime. And you can install the meter yourself. On top of that, you tackle all challenges of the nuclear density meter, like employees who are not afraid to perform checks and repairs, and no need to schedule the presence of specifically trained personnel. No more challenges when transporting nuclear sources. So basically, with the use of the ADM, all the hassle will be gone.